the video on surface plate and height gauge measurement. Today we'll talk a little bit about the surface plate, what it does for us. A surface plate is a precision instrument in that it is a ground, pink granite in this case, instrument. As you can see in the handout, that damaged areas do not produce raised material. If you were to ding this, the material itself, the rock or granite in this case, would not rise above the normal surface. It would take the gouge down into the part. You have different grades of AA, which is laboratory, grade A, which is inspection grade, which this one is, and grade B, which is tool room grade. In this particular case, this surface plate is flat within 4/10,000ths of an inch. In your handout, it talks about surface plate care. You keep the granite plate uncluttered. You don't have a lot of things on it. You keep it clean, covered when not in use, and you inspect it regularly for damage, dirt, grime, whatever. And then, of course, you have it regularly calibrated. Various height gauges that I have in front of you include a vernier height gauge, a dial height gauge, also caliber if you will, and a digital height gauge. And briefly I'm going to talk to you about how some of these measurements are taken. When you actually fill out the inspection sheet, I will have the initial data already recorded for you, and then you will be able to calculate the averages. But quickly, if you pull out your sheet, we'll talk a little bit about some of the dimensions that will be measured with the height gauge. For instance, the first measurement we will do is with the vernier height gauge, and the part we'll be using is G, and it looks just like the picture. Okay. First, you go in and you verify that the device registers 0 when it's measuring the height, as you can see. On a vernier height gauge, you look first at the 0 to make sure it's lined up, and then you would look up from 0 to 25 because it's in 25 thousandths increments on up to 100 thousandths, and that's how you would check it. In this particular case, A is from the surface here to the top of the part. A. In this case, it actually measures 1.500. And as I said, I will take other dimensions later for you. The dial height gauge is similar to the vernier in that it too must be first zeroed on the surface, and then the dial has to be zeroed. Press these little buttons to make sure that it goes to 0, and then you raise the part up, or should I say the gauge, then you lower it down to the top of the part. In this particular case, you can see the 1.5, and then there's a 0.1 because there's 100 thousandths all the way around. So I'd already measured once, as you can see, 1.5. I'm going to write down 1.501 in this measurement. A lot of things can affect the measurement of a part. A little bit of dirt, maybe even a little bit of rust on a part sometimes. If I were to lay this and flip this over, as you can see, that G is embossed down into the part, and that raised surfaces on the metal. And this is another reason why surface gauges or surface plates do not use steel, because as you can see, when that was embossed, it raised the metal somewhat. This granite surface will not do that. Next, we use the digital height gauge. We take it down to verify that is 0. I had already zeroed it, as you can see. And you bring it back up to the top of the part, and you measure. It's 1.498. The last time I measured, I obtained a 1.499. So I'll write down 1.498. In your case, when you do the laboratory, you're going to write down, or should I say type in the Excel spreadsheet, the 3 values, and then calculate an average for all of the white cells. When you do this, anytime you measure, you should always measure at least 3 times, because you will get variability from one measurement to the next. And this is another good way to make sure that you are getting good, valid measurement readings. Other things that I wanted to point out real quick, and we will just use this digital height gauge. Like for instance, B, we have right here, digital height gauge. B is from the center of this slot down to the bottom. Now, the best thing you can do, keep in mind, we've already zeroed this, is the best thing you can do is go down and you're going to touch the bottom of the slot. It's 0.752. And then you will take a gauge pen. This particular gauge pen was 0.498. I did not list this in the requirement of measurement for the laboratory because I'm just giving it to you. But here you go. You put that in the slot. You take the biggest gauge pen that will fit without skiving metal off the gauge pen or off the part. And then you back it off by 1/1000ths. One that's tight and then one that's looser. In this case, 498. Divide that by 2. Add that to the dimension that we obtained, 0.752, and then you have your B dimension. Now, similarly, you will do the same thing when you measure this dimension, which is right here, as you can see, is C to, I have the wrong gauge pen, hold on a minute. C is to this particular hole back here, and I have a 0.246 gauge pen. In this particular case, the height gauge will not go in the hole, or should I say into the slot, because there is no slot. So what you do is, since I'm already zeroed, I'm going to go to the top of the gauge pen. I'm going to read the dimension, 0.626, and I'm going to divide the diameter of the gauge pen, which is 0.246, divided by 2. Subtract the difference between the two numbers, and I end up with my center line to the bottom of the part dimension. And that's how you will obtain the C dimension. And D, you will do the same thing. In this particular case, 0.498 pin works very well in that hole. And let's see, there's other things that I wanted to point out to you. When this particular part is measured, and if you look closely, you'll see what I'm talking about. We have various dimensions that you would measure from here to here, and from here to this step, and here to the overall length of the part. But we also have a dimension here called K, which is also in the digital height gauge. K, in this particular case, is very difficult to measure. And really all you can do with the components that we're using and the instruments we're using is make sure you're zeroed down at the bottom, and then you are going to eyeball the actual height. In this particular case, I had 0.733. It will vary depending upon how you look at it, and hopefully you're parallel with the surface plate when you look. That's all part of it as well. And as you can see, other dimensions on here, that's what you're going to get on the sheet that I provide you. And then you'll have a chance to do the average. Make sure you fill in G for the part, as well as your name and the date. Type all that in, save it as an Excel file, and then you will turn that in for your laboratory. And that will help you understand this a little bit better. And remember, you need to look at the supplemental videos that are already available for you in Blackboard. Thank you for joining me today.